Question 29. For a polynomial px, the value of p3 is -2. Which of the following must be true about px? In order to solve this question, you should use some mathematical skills and some maybe proving skills as well. If you see here, it says some kind of term is a factor of px, or the remainder when px is divided by x3, which some term is -2. So we want to prove that some term x, let's say x plus k, is a factor of px. So in order to do that, let's say if we divide px by this x plus k, you would get qx and a remainder. If you move this into here, which is px into x plus k into qx plus rx plus k oh, excuse me, it's not rx, it's just r. Yeah. And you should change this as r. So if you divide px by x plus k, you would get a quotient, which is a function, and you would get a remainder. Because you divided the polynomial with this, how can I say, a 1-degree polynomial, the remainder would always be a real number. It's not an imaginary number, but it always exists. Like, it could be a rational number or like integer, but anyways, it's a real number. So to make it convenient, I change it to this form. So now we could plug in all the values one by one. But okay, for a, before plugging in these a, b, c, d, you should use this information that when p3 is -2, when p3, the value of p3 is -2. So you would say, okay, -2 is equal to p3, which is 3 plus here k and q3 plus r. Now we got this equation after all. Okay, I would recommend you to write all these equations, and I would now erase this part for further calculation. Now we got this equation, so we'll plug in all the values in it. So when k is -5, it becomes -2, -2q into 3. Oh, sorry. It should be without bracket. But this could be true, but this is when only q3 is 1. So the value of quotient is limited. That's what I mean. But the equation should be true for all the value, no matter what this is. So I think we could say the same thing for all these values by plugging in the value. It is limited, but this one, the special situation, a specific situation is given. The remainder when px is divided by x minus 3 is negative 2. So if we put in this value in here, so x minus 3, and we put this here in the place of k. Now q3 is there, plus 3, then negative 2. It's 0 here, which means that 0 q3 plus negative 2. This is possible for all the values of q3 because if I write this equation again, 0 multiplied by q3 is always 0 because no matter what, this is 1,000, 10,000, billion, this is 0. So the value should be always 0. So 0 plus negative 2 is always negative 2. The remainder is always negative 2 when it's divided by x minus 3. Therefore, finally, the answer is D.